Okay, today's lesson we're going to be talking about central angles. Okay, so first to introduce central angles, we need to talk about the definition of a circle. Okay, so on your screen, as you can read, it says a circle is the collection of all points in the plane that lie a fixed distance from a fixed point known as the circle center. Okay, and so as you can see down here on the screen, here's your circle. All right, and so your radius. Okay, I see three different radius here. I'm going to color them one in blue. So there's one. There is two. And there is three. Okay, three different radiuses. So we should be familiar with that term by now, okay, because we've all seen how to find the area of a circle, so we should already be familiar with what a radius and what a diameter is, okay? A chord is something we are not familiar with, so I'm just going to introduce that one. So a chord is a line segment that has both of its endpoints on the circle, okay? So a chord would look something like this, okay? So we got DB here. This would be an example of a chord. And also DC. Would be an example of a chord. Okay. One that is not is AB. So as you can see, one of its fixed points is on the end, or one of its fixed points is on the circle, and its other end point is on the radius. Okay? Or on the center. So therefore it is not an example of a chord. Okay? So those are the difference. So it says, exercise 1. Circles are often denoted by their center. In the following diagram, circle A is shown with points B, C, D marked on the circle. List 3 segments that represent radii of the circle. We've just demonstrated that, okay? So we can see that AD is one, AC is another, and AB. Give the segment that represents a diameter of the circle, okay? You would say DC. And it says, what is the relationship between the length of a diameter and the length of its radius? Why? Okay? So, for example, let's just say the radius is 5 for this particular circle. So that means this radius right here is 5. That means this one is 5. And that is also 5. And so when you add both of these segments up, you get 10. So therefore, our diameter, in this case, DC, is equal to DA plus AC, which in this case, AC and DA are both the same. And so there's our radius. And so this shouldn't be too unfamiliar with you guys, but we're just going to continue on here with the next question where it says, okay, list all the chords. So in this case, we would say AB, but we would also say DC because both of its endpoints lie on the circle. So it says, explain why DAB must be isosceles. Well, already kind of just mentioned that if both of these are 5, okay, that means we have a triangle with 2 congruent sides, which by definition, whoops, isosceles triangle because it has two congruent sides. Okay, so exercise 2 says, in circle M, point A is located on the circle such that AM is equal to 2x plus 7. If the diameter of the circle M is 74 units long, and then what is the value of x? So let's get a circle up here first. Okay. It's not going to be perfect, but that looks somewhere right here in the middle. Okay, so there's our circle. It's M. This is our diameter is 74 units. So I'm going to draw a line through that point. And that is 74 units. So what is the value of x? So we need to set a point M, point A. And so what is what is x in this particular function here? So in order to find that, we first have to look at this. Okay? So if our diameter is 74 units, what is our radius? I'll give you a second to determine that. Hopefully you guys realize real quickly that the answer is 37. Okay. So now we're going to take this number here and we're going to do what with it? Well, if you set our equation equal to 37, you are correct. In this case, the value of x, 15. Okay. Moving on to the next one. So in the diagram, circle O, below, points A, B, C, and D all lie on the circle with diameter BD. So name the minor and major arcs that have A, B as their endpoints. Okay, so first I'm going to draw a line from A to O, and O to B. Okay? Just say name all the minor and major arcs that have A, B as their endpoints. So when we're talking about the major and minor arcs, we're talking about this right here, a particular length, and all the way around the other side. Okay? So it accompanies the whole circle, just one of them is obviously larger than the other. And so if you guessed it, the minor arc is always going to be the smaller one. Okay? In this case, you can tell because they give us a diameter right here. You can see that diameter. Okay? So we know that this right here, here to here, is 180 degrees. And to go back around, clearly would be 360. Okay? So in this case, our minor arc, AB, okay, some more terminology, is going to be written like this. Okay? This denotes the minor arc. And as you can see, there's no points in between here. But if you notice on the other one, we got how many points in between? 2. Okay, so to help distinguish one from the other, we must include at least one of those points. Okay, maybe both if you'd like to. I'm just going to include D. Okay, but you must make sure that you're following in sequential order here. Okay, don't put B before D, because if we're going this direction, D comes before B. Okay, and there's my arc. All right, so name the minor arcs that have A and C as their endpoints. I'll give you guys a second to figure that one out. Okay, so our minor arc is going to be AC. Our major arc, I'll go ABC. I could have used CBA. Just make sure you're putting things in the right place. All right, on to the next one. So for you guys, your homework, I just want you to try this one. And that one. Okay. I think those are your first two homework problems. Okay. So, a central angle of a circle is any line that has the center of the circle as its vertex. Okay? So we typically designate that angle by using 2 points that lie on a circle and the circle's center. Okay? So circle B is shown below with various points located on it. Which angle below is the central angle of the circle? So first off, we're going to need this point right here, okay, because that is our vertex. None of these other points here, or I'm sorry, none of these other points here are on our center. I'm talking about B. B is our center. That is our center point. So if you take a look, okay, look at all of these, which one of these has B as their center point? As you can see, I located it last. It was this one. So if you look in the other ones, DAE, okay, that's no good. Okay. CEB, okay, our vertex is here, so that's no good. Whoops. So ACB. As you can see, our vertex is located over here, so no. And last but not least, it has to be CBA because its vertex lies on the center. Okay, so that's what we refer to as central angles of a circle. The vertex has to be located on the center of the circle. Okay, so for homework, I want you to try these two. Try these two. And try these two. Okay, so in the first one it says if an arc is given, I'm sorry, the second part, if an arc is given, name its central angle. So major arc for 1, you would say. AB would be the minor arc, right? So it wouldn't be AB. The major arc would have to be B, C, A. Okay? So we'd have to say B, C, A. That's what it means by major arc. Okay? So if it said minor arc, it would say BA. But because it says major, we look at angle 1, So this is the minor arc for angle 1. So BCA would be your major arc. Let me try one more. Okay, how about this one? Give yourself a second here. SVT. You're looking at the arc for this one. SVT, which means we're going all the way around. So what angle refers from here all the way there? And if you said SQT, you are correct. Let's try the last little part here. Okay, so now that we know what a central angle is, we can define the measure of an arc. So we say the measure of the arc is equal to the measure of the central angle. So all this is saying is that this arc length, or the measure of the arc, I'm sorry, is equal to how many degrees that is. And that's all this is saying. The measure of the arc is equal to the measure of the central angle that it intersects. And this is only for central angles. Okay? So in the diagram of circle D, shown to the right, the measure of ADB is equal to 112 degrees. So what is the measure of AB? We would say 112 degrees. But then what is the measure of ACB? Okay, so now we're not talking about that one anymore. We are talking about going all the way around. Okay, and so a circle is 360 degrees. Okay, which if you guys all skateboard or snowboard, or just, played around on the trampoline, we've all should be familiar with 360s. It means just to go all the way around. So to go all the way around would be 360 degrees. So this measure right here, if this is 112, that means this right here is 360 minus 112. Give you guys a second with your calculator. And it is 248 degrees. Okay? And that is about it for central angles. Okay, so for the rest of this is for homework, right? So hopefully I've given you guys enough information to solve these problems. We'll try one of these down below here. I want to try 17 with you guys. And maybe one with 16, okay? So, let's take a look at number 16. It says, assume that all lines which appear to be diameters are actual diameters, okay? So this right here is what they're referring to as your diameter, okay? Which means this angle measure is 180 degrees. And we know that because that is a straight angle. Now what these two symbols mean, okay, is that these two pieces are congruent. So if you know this is 180 degrees, and these two things are being split up in half, we know that this equation must be equal to 90. Right, and in order to solve, this is equal to -3. Plug that value in, and what do you get? 90 degrees. So you never can really quite assume anything, right? Usually we see this kind of symbol in there. But in this case, we have just shown that it has to be 90 degrees if those two pieces are equal over there. Now let's look at 17 and call it a day. So we know that this piece is the same measure for right there. Okay? And we know that this piece is represented by this number. Okay? What do we suspect about these two angles here? Because I see a line, and I see another intersecting line. So what do we know about these two angle measures? They must be equal. So in this case, we would go 1, 2, 1, 2. All right? So, that being said, we know that this piece must also be equal to this piece then. So if these two are congruent, then these last two pieces must be congruent. So I'm going to set both of these equal to each other. Now we see two of these, so I'm going to say 2 times 5x plus 10. Distribute the 2. Whoops. Similar lines which appear to be diameters are actual diameters. So does that actually work out? Just plug it back in. Must have made a mistake back here in the math. Oh, it's a 12. Shoot. Yep, that'll make a mistake there, won't it? Alright, let me clear some more space here. It'll be faster. Well, let's try that again. Minus 10x, minus 10x. 2x minus 2 is 20. Oops. Is equal to 20. Plus 2, plus 2. That looks better. Alright. 12 times 11 minus 2. That's 130. Anyway, see if you can find out my mistake here, guys. But you're going to want to set both of these things equal to each other. Somewhere I am losing something. So, anyway. Oh, Well, that makes sense because these things should be 1/2 of this. Okay, we got it. If this is 130, that means both of these are 65. Hello. Okay, and that concludes this lesson. Hope you guys doing all right.